hackathon is an event where various people get together for a period of time and work on and try and solve various computational problems.
It's a very informal event that gathers together people from any background with the common interest of tackling specific problems.
A hackathon is an event that groups people from different backgrounds and universities, and they group to work on different projects so that afterwards new collaborations and new works can be done and pushed into papers or publications.
This hackathon in particular is about visual computing, and so it's very computational, and we have people from all over UK and Europe came here to work together and code together, making software.
So we've got a variety of projects from across visual computing, and in particular we've got quite a lot in the field of medical image computing, which I think is really good because that shows how computer science can be used to have real-world impact.
So we've been designing a software package called Microtorch, which is to flexibly fit different diffusion MRI microstructure models using self-supervised deep learning.
I work on magnetic resonance imaging, and when we have patient motion, the data becomes inconsistent, so we have to reacquire the data. And correcting for patient motion takes a bit of time, so we cannot do it in real time, but a lot of patient populations are susceptible to not being able to stay still throughout the scan. So we try to develop some machine learning methods to estimate the effect of motion on ultra-high field MRI and correct it on the go.
I've been working on one called DiffSimGen Micro Guide, and the idea was to bring together two toolboxes. So the one that I was working on is this diffusion signal generator, so you give it a set of parameters and it simulates the diffusion signal.
So one of the issues that we generally have with MRI is that we're not sure how to be confident in our parameter estimates that we derive. So the goal of the project was to create an automated tool which can tell us the uncertainty and ambiguity of our MR measures. And this can be very useful, for example, in disease states, in interpreting the maps, and also in just learning something new about the brain.
So the project I joined is about making an app for cell phone that can read and process medical images, such as those acquired in the hospital, where a clinician can upload on their phone an image, can visualize it, can process it, zoom in, zoom out, rotate, identify anomalies in the image, and perhaps aid the diagnosis.